Today my topic is pathology of blood and urine. Presenting by me Gunjan Gadge from Ravi Institute of Diploma in Pharmacy. Content: Introduction to pathology, what is blood, function of blood, composition of blood, lymphocytes, erythrocytes, platelets, and disorders of RBC and disorders of WBC. Pathology. What is the meaning of pathology? Pathology is a branch of medicine that deals with the laboratory examination of sample of body tissue for diagnostic and forensic purpose. Pathos means suffering and logos means discourse. In this, what is blood? Blood is a fluid connective tissue which circulates in a closed system of vessels. It consists of plasma and serum. Serum is a transparent colorless fluid and minute solid particles or corpuscles immersed in it. 45% of blood cells are suspended in 55% of liquid medium. In this, the blood are divided into three types: RBC, WBC and platelets. RBC are erythrocytes, WBC are leukocytes, platelets and thrombocytes. In this, the composition of blood. Composition of blood deals with it consists of two parts: cellular fraction and plasma fraction. Cellular fraction are three types: RBC, WBC and platelets. Plasma fraction are divided into two types: protein and non-diffusible constituents and diffusible constituents. Non-diffusible constituents are albumin, globulin, plasminogen and enzymes. Diffusible constituents are hormones and vitamins, anabolic constituents, electrolytes and catabolic disorder. Reflection spot. What is blood and write the functions of blood and the normal range of blood. Functions of blood. In this, blood transport oxygen from lungs to tissue, carbon dioxide from tissue to lungs. Blood transport absorb nutrients from alimentary tract to tissue and carry waste product from cells to excretory organs via kidney, lungs and intestine. It regulates body temperature and blood pressure. Blood protects the body from hemorrhage. It maintains water balance of the body. Defense mechanism of the body maintains WBC. Blood acts as a vehicle for transportation of hormones, vitamins and essential chemicals. In this, the blood transport mainly absorb nutrients from alimentary tract to tissue. It also carries the waste products from cells to excretory organs. Excretory organs are kidney, lungs and intestine. The main role of blood is also to maintain the body temperature and blood pressure. It also protects the body from hemorrhage by the process of coagulation. It also maintains the water balance of the body, and the main defense mechanism of the blood is to maintain the WBC. Blood also acts as a vehicle for transportation of hormones, vitamins and essential chemicals. Leukocytes. Leukocytes are nothing but the WBCs. WBCs are white blood corpuscles. In this, WBC are irregular, nucleated, colorless, large in shape than RBC. It is 10 to 14 micron. They are also produced in bone marrow, lymph nodes, tonsils and spleen. The phagocytosis causing microorganisms are eaten by the diseases. They act as a defense mechanism. As the number of leukocytes increases, the number of natural cells also increases. In this case, the 20,000 is in newborn and in pregnancy it is 10,000. Depending on the cytoplasmic nature and lobulated nuclei They are classified into two types: granulocytes or granulocytes. In this, the granulocytes are neutrophil, eosinophil, and basophil. Organocytes are monocytes, lymphocytes, both. Then white blood cells. These are granulocytes and organocytes. In this, neutrophils having phagocytosis and other pathogens. In eosinophils, there is the control mechanism associated with the allergy. In basophils, it contains histamine and heparin. It also releases histamine from the basophils. And monocytes are phagocytosis. In this, neutrophils are also phagocytosis. Lymphocytes is the secretion of antibodies. Then monocytes and lymphocytes. These both basophils having 3 or 4 lobe nuclei. Eosinophils they are having bilobed, and in neutrophil, they are having 3 to 4 lobe. In eosinophils they are having 2 lobe. In basophils they are irregular in shape. Granulocytes. The presence of cytoplasmic granules 2 to 5 lobe nucleus. Depending upon the staining reaction with dyes, they are further classified into neutrophil, neither stained with acidic nor with alkaline dyes. In this case, it is acidic as well as with alkaline dyes. They have 5 to lobe nuclei, and the cytoplasm is full of lysosomal granules. In this, the phagocytosis cells of WBC occurs. In this, there is engulfment of digest bacteria, protozoa, and cell debris. Accumulation of dead neutrophils and bacteria leads to the formation of pus formation. In this, eosinophils. Eosinophils are nothing but the stain passed with acidic dyes and acidophils. They are bilobed nuclei eosinophil phagocytosis. Antigen antibody complex also produces antitoxins. In this case, the eosinophil histamine responsible to produce allergic reaction. As there is a rise in the number of eosinophils, they are called as eosinophilia. And basophil. Basophils are stained passed with basic dyes. They are characterized by irregular nucleus. They also produce histamine and heparin. In this case, they are basophils and non-phagocytotic. Granulocytes. These are non-granular and they undergo mitosis. And they are further classified into lymphocytes and monocytes. They have a spherical nucleus. Non-phagocytic. Produce antitoxin antibody. Help in healing wounds. UV rays increases the number of lymphocytes. They produce beta, gamma, serum globulin. The monocytes are containing kidney-shaped nucleus and they are phagocytic in action. They are found around inflammation and help in removing the damaged tissue. Erythrocytes. Erythrocytes are what? The red blood cells corpuscle. Small circular minute disc-shaped bodies. Biconjugate non-nuclear suspended in blood plasma. Number of RBCs increases as they are in the age-sex physiological condition of the body. They have no nucleus and having special protein known as hemoglobin. The non-protein material is in heme. The complex protein material is globin. It is a yellow-colored pigment which is having an effect of making the blood red. And so, it contains little amount of iron and having a great attraction of oxygen between them. Are produced in liver. In fetal life after birth, the average lifespan is 120 days. The generation and the formation of RBCs in red bone marrow is called as erythropoiesis. In this, the bone of RBCs are removed from the bloodstream and destroyed in the liver and spleen. Means RBCs have completed 120 days, they are removed from the bloodstream and destroyed in the liver and the spleen. Function: transport oxygen and carbon dioxide and maintain acid-base balance. It also maintains iron balance. It also maintains the viscosity of the blood. The process of formation of red cells occurs in the presence of iron and vitamin B2. As I told you that the RBC cells are biconcave in nature, they are having no nucleus and it is disc-shaped and having biconcave in nature. As the diagram shows that it is an RBC. Platelets means somates. They are derived from the red bone marrow, that is megakaryocytes. They are non-nucleated discs consisting of cytoplasm enclosed within the cell membrane, but contains organelles such as Golgi apparatus, mitochondria, and filament. The lifespan of platelets is 8 to 11 days, and the normal lifespan is 7 to 14 days. Role initiating blood clotting, involve healing of wounds in endothelial lining of vessels, involved in homeostatic mechanism. Disorders of RBCs and disorders of WBCs. In this case, the disorders of RBCs are anemia. In anemia, there are subtypes: pernicious anemia, sickle cell anemia, megaloblastic anemia, iron deficiency anemia, and hemorrhagic anemia, and hemolytic anemia. Polycythemia in this, the relative polycythemia and absolute polycythemia. In this case, the disorders of WBC, that is proliferative disorder, is leukocytes, neutrophilic, eosinophilia, basophilia, and monocytosis and lymphocytes. And leukemia. Second is leukopenia, neutropenia, eosinopenia, and lymphopenia. Disorders of RBCs are anemia. Anemia in this case, the decrease in the oxygen and carrying capacity of the blood can also cause anemia. It also depends on hemoglobin content of erythrocyte. The reduction in the blood hemoglobin level and the number of circulating erythrocytes indicates anemia. When there is reduction in the hemoglobin level and in the number of circulating erythrocytes, they are causing anemia. Pernicious anemia. In this type, anemia is essential factors which are absent that leads to the insufficient homeostasis. Megaloblastic is microcytic anemia, which is deficiency of vitamin B12, that is an extrinsic factor. Sickle cell anemia is a genetic disorder in which the bone marrow produces the abnormal type of hemoglobin. The shape of large number of red cells is like a sickle cell patient with sickle cell show marks susceptibility to in this iron deficiency and microcytic anemia. Due to inadequate absorption of iron, excessive loss of iron, insufficient intake of iron. Aplastic anemia is due to destruction of red bone marrow. Hemorrhagic anemia is excessive bleeding due to large wounds, ulcers, and heavy menstruation. Polycythemia. It's a type of blood cancer. It causes bone marrow to make too many red cells. This can thicken your blood and slowing is which may cause serious problems such as blood clots. RP and AP. Relative polycythemia and alternative polycythemia. Decreased plaque volume means RBCs increase and increase in the secretion of erythropoietin. Later on we will study the disorders of WBC.